Well, we have this complicated force question, and what we need to do is draw a free body diagram. So we have this force F going diagonally like this. Now we're told that there is friction, so we'll put a little force of friction there. We have an unknown tension, and we have this gravity weight force pointing down, as well as a normal force pointing up. One other thing I want to point out is that this little force F here, this horizontal force, we need to be careful because it actually has two components. It has a horizontal Fx component and a vertical Fy component. Now we want the coefficient of friction necessary for the box to be moving at constant velocity. So let's be clear. In the horizontal direction, we have forces Fx plus tension going one way. They balance the friction force such that the box moves at constant velocity and the forces are balanced. In the y direction, we have the normal force and Fy also pointing the same way. They compete with the weight force or the gravity force, and the effect is that the forces cancel since the box doesn't accelerate in that direction. Now let's put in some numbers. So Fx and Fy, we get that using SOHCAHTOA. Fx is 200 times the cosine of 30. Fy is 200 times the sine of 30. So this ends up being 173, whoops, gross. This ends up being 100. Putting in our numbers, we're going to have here 173 plus the tension, which is 80, minus the friction balances to 0. So this is going to give us a friction force of 253 newtons. Yippee. Now, let's get the normal force because we're going to need that for the coefficient since friction is mu times n. And so far what we have is that a 253 newtons is going to equal mu, and we're going to get Fn in a second. So we have Fn, unknown, plus Fy, which is 100, minus gravity, 650, because remember that's m times g, and that's m right there. So we're going to end up getting that Fn is 550 newtons. So now we can actually plug that in here. F equals mu n is 550. And when we solve for mu, we'll actually end up getting nice, 0.46. Very cute. I'm really choosing these adjectives that have nothing to do with the problem. I don't know how this is cute in any way whatsoever. I believe it's correct. That works. All right, determine the acceleration of the box if the box is on a frictionless surface. So now, since we have acceleration and no friction, what we can say is Fx plus t equals ma. Here we go. 173 plus 80 equals 65 times a. So we're going to end up getting 253 equals 65a, and our acceleration is going to end up being, let's just get the math real quick, so 253 divided by 65, it's going to give us 3.89 meters per second squared. I can scarcely believe my luck. Actually, I can believe my luck. This is a very believable number, and I don't know why I thought that would be some kind of lucky thing. Okay, so there we go. All right, so that is the second to the last page on the exam.